Hi everyone, you're welcome to the part 2 of Indices. I am Hajibade. Okay, so just a quick reminder of what base and power is. And then we were able to explain the first three parts of this laws. Now today we want to take the last three parts of this law. We'll be looking at law 4 here, which is b raised to power x and everything raised to power y. When you have a situation like this, what you do is to multiply x and y. You have the same. If you look at this law 4 and law 5, you see that they are similar. What this is just telling you is that when you have the power, when you have inside the bracket, you have one more than one value. It means that that power is going to affect each of the values. So that is why a is being raised to power x and b is also raised to power x. And the last one here is b raised to power minus 1, which is equal to 1 over b. All right, we are going to be taking examples for better understanding. Example 1. If you have p raised to power 5 raised to power 4, all you have to do here is just multiply the powers together. Then that will give you p raised to power 5 times 4 will give you 20. As simple as that. Example 2. Here we have 5m squared n raised to power 3 all raised to power 5. Now, a quick reminder of what we used to do in junior school. If you have x squared, it means x times x. So if I write this, it's the same thing as 5m squared n raised to power 3 times 5m squared n raised to power 3. That is the meaning of what you just have there. So law of indices is just making us to work faster. Okay, so if you have this to do, what do? You multiply 5 times 5 to get 25, isn't it? Then if you have n raised to power 2, m raised to power 2 times m raised to power 2, it means m times m times m times m, which will give you m raised to power 4. And if you have n raised to power 3 times n raised to power 3, it means n times n times n times n times n times n, and that's going to give you n raised to power 6. And because we don't want to be counting m times m times n times n, because we can have bigger values, and that is why law of indices is applicable in this case. So let us apply the law of indices to this and see what we are going to have. Okay, so if you look at this question, we have 5 raised to power m squared n raised to power 3 then 2. Then what you would do is, this means 5 raised to power 2 using the law. Then we have m raised to power 2 times 2, right? Then n raised to power 3 times 2. So the law of indices is just simply telling us, the law of indices is just telling us that this is going to give us 25 m raised to power 4 n raised to power 6. So law of indices will save us the stress of adding up one after the other. Okay, so let's look at another example. Because of the knowledge that we have now, we can do this better. All right, so let's go. 3 raised to power 4n times, okay, we have everything being raised to power 2. But mind you, here n is a power, so this 2 is going to multiply this power, while this 3 keeps staying here and waiting for these brothers to be multiplied. So we have 3n times 2, and that's going to give us what? It's going to give us 6n. Very easy. Now, what do we do? From here, let's go back to our first law, where we have the same base, which is 3, and then we have a multiplication in between. We pick one of the bases, which is 3, and then we add up the power, which is what? 4n plus 6n. And then this is going to give us 3 raised to power 10n. If this is clear to you, give me thumbs up. Let's see another example. Example 4. Now, in this case, we will be applying the rule of b raised to power minus 1 equals 1 over b. Okay, so from here, what do? We are told to find p. So we say 3 raised to power p equals, now I want to change this 1 over 9 to look like this format. So I can write this as 9 raised to power 1 minus 1. Compare with this, you see they are the same. Now I can decide to change this 9 to have the base to be 3. So this will be 3 raised to power p equal to 3 raised to power 2 all into bracket minus 1. Now, if you look at this critically, you see that I have not changed anything. Nothing is changed yet. So you look at this, 3 raised to power 2 is the same as 9. So if you now apply the law by multiplying this out, this is going to give you 3 raised to power p rather, equals 3 raised to power minus 2. All right, friends, let's look at this. This equal to is not multiplication, neither is it division. So in this case, you're not going to add together. What you're going to do right here is to break down these bases. The bases are the same, so you're going to break them down and carry the power, equate them. So this is going to give you p equals to minus 2. Oh, math is easy. All right, let's move to number 5, which is our last example. So if you have something like this, how do I go about it? Remember, I just told you now that b raised to power minus 1 can be written as what? 1 over b, right? Now, so let's go. 1 over 2 can also be written as 2 raised to power minus 1. So if I put it in the bracket and I then say x plus 4 equals 8. Now, I can expand the bracket. By expanding the bracket, I have 2 raised to power minus 1 minus 4. Remember, we are multiplying with a negative sign. So I can rewrite my 8 to have a base of 2. So if I write 2 raised to power 3, it still means 8. Okay, looking at this, oh, pardon me, this is meant to be x. Okay, if you look at this, you realize that the 2 here can be striked out. So this will now be what? Minus x minus 4 equals 3. Now let's help ourselves for the people that does not like dealing with negative, because we are looking for x and not negative x. So I prefer to cross this negative x to the other side so that the sign will change to positive. Then I bring this 3 to this side so that it will also change to negative. So if I bring this, it becomes minus 3 minus 4 equals x. Dear friends, minus 3 minus 4 will give you minus 7. So I have minus 7 equals x, which implies that x is equal to minus 7. If you have enjoyed this class, subscribe and share with your friends. Thanks for your time.